All right, you back to the one screen slide, yes?
Yep.
Okay, so yeah, so I'm talking about StrictMoney, value objects in practice. This has nothing to do with my talk, but I feel like I need to throw it out anyway, because that's the kind of couple weeks we've been having. Yeah, let me start by talking about myself and some of the tech work I do that has led me to write this library. I'm an independent software consultant. I work a lot with teams doing Ruby backends. I work on architecture, organizational processes. I got a chance to create a value object for a software project I was on not too long ago. And I kind of wanted to kind of go through a quick demo of sort of like what value objects are, why Ruby is so good at them, at kind of making custom value objects. So the basic definition of value object done by Martin Fowler. It's a small, simple object like money or a date range, whose equality is not based on identity. You know what? I'm really sorry. I gotta tweak a thing right now. Am I like?
You're comfortable. Do it right.
It's how do I change my Okay. I'm gonna look at this screen. All right. Anyway, yeah. So a value object is a small, simple object whose like a money or a date range whose equality is not based on identity. So what do we mean by that? So when we say equality isn't based on identity, for example, let's say you had two user objects with the name, first name and last name of John Smith, right? If you compare the two of them, how do you want these classes to behave? In fact, in this case, you actually want those two to be false, to be not equal to each other, because we know that in the real world, there are multiple human beings named John Smith. And the combination of the first name and last name is not what gives them sort of a unique identity, right? In contrast, if you imagine like coordinates, like XY coordinates on a two-dimensional graph, and you have a 16 and 8, when you compare the two of them, you actually want those two to be the same. But it's worth noting that in Ruby, this is not based on identity. Chords 1 and chords 2 are actually separate Ruby objects. They have different object IDs. They occupy different space in the Ruby process. But because they're 16 and 8, they are effectively the same thing. What's tricky about, hashes are a common way to try to represent value objects, but what's tricky about them is hashes are mutable, which can cause kind of bugs that can be a little mysterious and waste a lot of time. So if you imagine you have a method called move chords, and you're saying, let me add the dx and the dy inside this chords. What actually can happen if you call this is now you're going to change chords by accident as a side effect. So at the end of this code, not only is new chords 17 and 7, but the old chords, the original chords object is also 17 and 7, right? So it's actually very hard to write a method in a way that whoever's calling it can know, is this going to change the thing I pass into it? So often with value objects, the value objects have to go alongside with immutability, where you just say, well, I'm creating a new copy of the thing. I'm not changing the existing objects in place, and that just kind of eliminates this problem entirely. So when are value objects a good idea? There's some good signs that you have a good use for value objects. One is if you have multiple primitive data elements like coordinates, x, y, date ranges, start date and end date. Often when you're writing a lot of methods and the arguments have the same sets of parameters in them, then that's often a good sign, right? If you have a bunch of different methods dealing with a x, y coordinate math, and you're going x, y, all in your method signatures, that's probably a sign that you want to figure out a good way to do a value object. This will come in handy if you want to define custom methods on those values based on the domain of what the value represents, right? If you wanted to calculate the distance between two coordinates, you could define that right on a coordinate class. If you wanted to have a date range and calculate the number of distinct calendar months contained in that date range, you could put that right on your date range class. The problem I was dealing with multiple currencies. We were writing a web front end for a programmatic advertising system. And we were starting to, most of this is actually done in dollars, even in a lot of the sort of the back end plumbing of the ad tech world is measured in dollars. But if you have a client in another country, they're often ask you to express what you're doing in their currency. So we had British clients coming along. The contracts were signed in pounds. And so even if there's a conversion happening at some point where you're saying, oh, we're going to bid at $1 CPM or whatever, you're ultimately, when it comes down to what the client cares about, it's all pounds. When I started thinking about what we're going to do, I think a little bit about what's a software architect's job, right? As a junior engineer, I've worked with a lot of architects of varying degrees of skill. But fundamentally, this is really, I think, the software architect's job. It's not the architect's job to design every class or to design every method, but it is the architect's job to sort of see, like, what's going to be the wrong thing that other people can't see right away and make it hard to do that. What's going to be the right thing, right? Make it hard to do the wrong thing, make it easy to do the right thing. And the ideal situation for an architect is if you can put those down not just in a README, but actually in a software library that then you give to the rest of the team and say, why don't you use this? This encapsulates a bunch of ideas. You don't even have to understand those ideas 100%, but you can use them and they'll sort of give you guardrails. So I was thinking about multiple currencies. I've worked with this in a bunch of projects. And a lot of the pitfalls have to do with accidental cross-currency math, and which often have to do with using the amount without the currency and then trying to add it back later. I've seen a lot of programmers pass around just the number without the currency, and then through 10 method calls, there's a bunch of numeric math, and at the end you're like, oh, that's US dollars, isn't it? Or maybe it's euros, I don't know, right? So I wanted to design a class that would make it really hard to make those kinds of mistakes. So in the SimpleMoney library, there's this class called amount. It's immutable, and a currency is tightly bound to a number. It encapsulates the notion that when you're dealing with a financial amount, it actually doesn't make sense to talk about a financial amount without currency, right? If you went to a store, if you went to a coffee shop and they said, and you asked, how much does a latte cost? And they said a latte costs $4, that's a nonsensical answer, right? It could be $4, €4, £4. And I wanted to be able to support fundamental mathematical operations that make sense, but only the ones that make sense. And then skip currency conversion entirely. I'll talk about that a little bit. So immutable, that's the easy one, right? You kind of just create this amount. You have amounts and currency. The amount is the financial amount. The instance variable amount is just, the numeric amount, right? And you can see below there, we have a StrictMoney amount new, 100 euros, right? And you actually just can't set currency, right? After you've created this, you can't change the numerical amount and you can't change the currency. That's all immutability really is in Ruby. It's actually pretty simple. And it's tightly bound to a number, right? So I decided not to create a 2f method, right? Ruby idiomatically has a lot of 2f, 2i, 2s. But I actually thought that was too automatic, right? I wanted to make it actually annoyingly difficult because you shouldn't actually do it that often. So there is no 2f defined on this class. There's only as float, and you have to explicitly pass the currency in. So it's just like enough of a pain in the ass. So if you call 2i or 2f, it raises a no method error. If you call as float with the correct currency, it will reduce it to just the number 100. But if you call as float with the wrong currency, it raises a wrong currency error. Right? So this is the code giving you guardrails. Somehow you got your hands on the wrong currency. Like, you should figure out where the error is in your code before you give wrong results to a paying client. This class supports comparison. Probably a lot of you guys know that there's the module comparable, right? You can use the sort of spaceship operator to compare it to another instance of StrictMoney amount. It only works if the other object is a StrictMoney amount with the exact same currency. And in that case, it just compares the amounts. It doesn't even try to do any other kind of comparison. So USD 100 is the exact same as USD 100 prime. There's a different instance of this class with 100 USD. It's less than 101 USD. You can't compare it to the number 50. That raises an error. You also cannot compare it to another currency. Because comparing what ended up happening as a result of making that strict, comparing negative or positive comparison is extremely common. And so I ended up writing these convenience methods. Because actually you can't just do, is this amount greater than 0? You have to do the as float to dereference it. And so another mathematical operation supports is plus. Now, some of you guys will know, some of you won't, that plus is actually just a method in Ruby. And you can define it on your own class. For example, just on fixed nums themselves, when you call 1 plus 2, which of course equals 3, that's the exact same as calling the plus method, right? So those two lines there are the exact same, pretty much the same Ruby code. Ruby parses space plus by looking for a method called plus on the object one and calling that. So you can define your own plus method, which is not something that is comes in handy all the time, but definitely comes in handy. So this basically lets you add two money amounts together, right? So 100 USD plus 101 USD is 201 USD. If you try to add it to just an integer, it raises an exception. If you try to add it to a different a money amount of a different currency, it raises an exception. But as long as your currencies are lined up, you can do a lot of basic math. Similarly, we can do multiplication. So there's a funny thing what happens when you start sort of defining the mathematical rules of this like set of objects, right? Because you can add currencies to other money amounts to other money amounts, but you multiply a money amount times just an integer or a float, right? So USD 100 times the number 5 is 500 USD, or times the minus 1. But of course, USD 100 times 100 USD 100 doesn't make sense and raises an exception. Subtraction is pretty much the opposite of addition. You're just subtracting. Division is an extra special case because you can divide a number, but divide a money amount by another money amount in the same currency or just an integer, right? So USD 100 divided by USD 50 is the number 2. USD 100 divided by the number 2 is actually 50 USD. But you can't divide across different currencies. And there's negation. So this is basically a way to to negate a money amount. Now, this is another kind of semantic sugar, right? So when you type -5 in Ruby, what it's actually doing is it takes the minus as a sort of a prefix. This is another specific case that's just kind of made it more readable. It's the same as calling the method minus ampersand on the object 5, which means you can also define a unary negation method on your value object. So again, to go back to this, right, all you're doing is just flipping it. So minus USD 100 is minus 100 USD. So now that we've got a lot of kind of basic math, so these are kind of just, they act like numbers, but they're not quite numbers, right? And you can do a lot of stuff with them, right? So let's say you have an array of spend amounts, and you want to add up, do math and just add them all up to get the total spend, right? You can define a method like this. Now, the second line of that method, spend amounts.sum, sum is a built-in method on the array. And what it does is it looks for the method plus, and it calls it consecutively on every object of that array, right? So we didn't have to kind of write our own iterating code. We just kind of used the existing piece of functionality on Ruby arrays already because of the fact we already had plus. You have to do that strict money amount 0 currency thing because you need a starting value, and you can't add 0, basically. Once you've got a total spend method, you can do other things, right? You can say, what's the average daily spend, right? So it just takes the total spend and divides by the number of days you've got, right? You could say, what's the total CPM? That's cost per mail. It's a pretty common metric in advertising, right? So you can take the total spend divided by the views, multiply it times 1,000. Now, I think one of the interesting things here, and one of the reasons that value objects are actually kind of powerful, is that these methods don't refer to currencies at all, right? They just sort of assume that, and in fact, you could probably just use numbers, but they're sort of just assuming, oh, these pretty much act like numbers in the way I need them to act. I could add them, I can divide them, I can multiply them. Next thing I wanted to sort of go through is how we deal with conversion. which is different, right? So up until now, we've been dealing with just a single value of a single financial amount with a number and one exact currency, but it doesn't say how those currencies relate to anything else. And we thought about this and we decided basically to kind of leave it out of the library because currency version is always a business decision. In practice, businesses record financial amounts in exactly one currency. So if you write a contract with a client, they're going to tell you what you're going to pay, what you're going to charge. Even if you've got a SaaS app, right? If your SaaS app starts in America and you charge $20 a month, and then you decide to open up support for UK customers, you're almost never charge them. You charge them. You're probably going to say, "Oh, we'll charge you £15 a month," or whatever amount you have, right? And in fact, then you're kind of owning currency risk. That's a business decision. That's typically what you do. Conversion happens for specific business reasons at specific times. There's really no good reason for it to be automatic just to make a computer programmer's life easier. And a lot of the questions about when conversion happens and how it's done are business questions. Who owns currency risk, right? If we are a company in the United States and we sign a contract with a client in the United Kingdom in pounds, we have to be okay with the fact that the currency exchange between US dollars and pounds could shift a lot over the next year or so. Now, in practice, developing countries or developed nations, their currencies aren't that risky, but if your contract was in Colombia or Pakistan, it might be like, you might think of it differently, but that's a business person's decision. That's not a programmer's decision. The other thing is how recent your exchange rates need to be, right? If you're, in our case, we just had a currency table that updated every night because we figured once a day was as accurate as we needed. But if you're actually like work at a hedge fund or something, that's probably not enough. But that's a business decision. So anyway, the library doesn't account for this. What it does do is say once you've done the conversion, we can store a value, and we call it a historical amount. So this is the value for a result of conversion. It stores two or more currency amounts that are assumed to be equivalent at some point in time. It's historical because conversions can only happen in the past, really. Exchange rates are historical observations. Right? At this moment, a second ago or a year ago, a US dollar was worth this many pounds. Here's our map. So a historical amount stores an array of amounts, right? And it raises the redundancy error just to make sure that in case you accidentally passed in the same currency twice. So if you have 100 USD and 88 euros, which was about the exchange rate yesterday, then you can make a historical amount by passing both of those objects in. If you try to put the euro 88 twice, it'll raise an error because you probably made a mistake. That doesn't actually make any sense. Comparability is very similar. It sort of assumes the other object has to be a historical amount and it has to have the exact same currencies. If it does, then we just pick the first one and we say this is probably good enough. For at addition, again, we're using this sort of semantic sugar that you can define a plus method. We basically say for each amount, first we check, does the other object have the exact same currencies that I have? And if so, let me cycle through each one and create a new object for the addition of each, right? Let me add my USDs, let me add my euros. So if you have now you have an object that represents 100 USD and 88 euro at the same time. If I wanted to get the one object, I could just pass an amount with USD. If I wanted to add the two together, I can just add them, and now that's 200 USD, 176 euro. But if I try to add with something with incompatible currencies, it'll raise an exception. Division and multiplication is very similar. You can actually do this with defined method. So unary negation. So for unary negation, multiplication, and division, just define a method and map the results of that method across each individual amount inside myself, and then return a new instance of myself. So if you take USD 100 euro 88, multiply times 5, that's 500 USD, 440 euro. If you negate it, that's minus 100 USD and minus 88 euro. And as a little, this is pretty trivial, but we added there's an as JSON on this, because what ends up happening, what we end up doing a lot in our application is serializing this data if there's a React front end. So you're passing all this report data, or really kind of any kind of dimensional data, say like, oh yeah, the price of this campaign was set at $2 CPM or whatever. But if you're in a multi-currency context, it's easy to just make this money object that then passes in the same value converted in multiple currencies. This came in really handy because, for example, let's say you've got a multi-currency ad campaign and you want to see the reports, and you've got a little selector that says, I want to see this in dollars. No, I changed my mind, I want to see it in pounds. You can sort of switch that in the front end, and you already have all the data. You just have to sort of re-navigate your currency keys down all these money objects to sort of show different numbers. That's pretty much it. You know, the takeaways, I would say, you know, you should consider value objects to increase cohesion. When, like I said, if you have multiple primitives that are passed together in a lot of methods all the time, you should think about making a value object that'll sort of like can be very convenient if you think of the right mathematical operations. Yeah, Ruby is a great language to be doing this in. It has a lot of reflection, so you can kind of, you know, all the stuff like addition and multiplication and year negation. You don't actually get that in a lot of other languages, so you might as well use it here. That's it for me. Thanks for listening. Do you guys have any questions or comments or thoughts?
First of all, thank you, Francis. This was really good and super useful with things that I'm considering and working on. If anybody has questions, just feel free to chime in a chat room or unmute yourself. I think everybody can unmute themselves, and yeah, feel free to chime in.
Have you implemented like the methods to serialize or to convert your money objects into SQL statements or things like that in a reliable way?
Yes. Well, so we were using Mongo. So we did it there, and I can walk you through it. In theory, it should be pretty easy to do an active record, right? So there's an ORMs, and we've only, Mongoid is what we're using. So what you do, that's just includes here. How does this work? Yeah, I mean, this is just kind of using Mongoid's API for generating a currency, but for custom serialization inside of Mongoid. But you could specify like, yeah, an amount, and then it would just kind of do that. It's sort of serialized, and this is deserializing it. I also wrote, there's a financiality validator, which validates, what's it validate? Oh, positive, yeah, you could say like positive, not negative, allow nil, and of course, you know, you could add more validation. I would imagine doing this in active record would be pretty simple. Yeah, we wanted to store my thinking in general was that, you know, when it comes to storing data, right, the data you store, data persist should be canonical when you can help it. So this actually was not, it was rare to actually store a multi-currency value with 2 or more currencies, but it was, I think, pretty valuable to be able to store the currency with the number. For example, like if you have an ad campaign that's priced in euros, every number inside of that is priced in euros. Like, so a CPM all the way down some tree of placements or whatever. And that would store in the database €50, right? Just to, again, it was like another way to make sure you didn't get your wires crossed, right? If you end up trying to refer to it as US dollars, then you messed up, and you should find out very quickly. You know, this is, in my experience, this is the kind of bug that like, it's the worst kind of bug because it's mysterious, and it could like live in production for like weeks until like some analyst somewhere is like, wait a second, these numbers don't add up, right? And then you're like, oh, we've been giving people the wrong numbers for like a month, you know? So I wanted to sort of make, like, yeah, these math errors are like really easy to like just let slip through. Other questions, thoughts?
Francis, what was the feedback from the team that you worked on? Did people generally get the architectural restrictions here? Were there friction in adoption? Did people want to just reinvent it and do something simpler?
I think people trusted my guidance because it wasn't the first thing we worked on together. I think if I was like brand new on the team and I was like, I have this thing, it's kind of a pain in the ass to use, like they might have been annoyed by it. But by the time we got to this problem, we'd all been working together for like 6-9 months. And so I think like, and the team I had was like 4 guys who were all really great, but also pretty junior. So I think they were happy to have that kind of guidance. I will say that like there was a period, and luckily I was kind of allowed to do this, where like we had to adapt a bunch of reporting code from a previous version of the website. So there's a bunch of Ruby code that we copied and pasted and said, like, okay, let's try to use this, save us some time. And it took a long time, I don't know, a couple of weeks or something, for me to just like push this money amount awareness through all these like layers of previously existing Ruby reporting code. So it was one of those things where I was like, guys, you're gonna have to trust me. It's gonna be worth it. It's gonna be worth it. And everyone sort of like, were like, okay, I guess we'll trust him. But then like 3 weeks later, like when it got to the front end team, one of the guys sitting on the front, they're like, oh yeah, this just works. Like it just always works. Like it's really hard to make a mistake. So yeah. Yeah, I mean, I'm not familiar with this project being used in any other code bases. There's always
just
what's the right amount of.
Wanted to get your feedback as far as like how because there is sometimes like a good idea, a good library is there, but it's somewhat difficult to get people to adopt it. I mean, I'm glad your situation seems to like worked out both from like people perspective and technology perspective. It was a good fit.
Yeah. What I would say also is that like you could imagine a little mini like so what's interesting to me is that by the way, there's a mainstream Ruby method of Ruby library for dealing with money. I think it's just called money, right? But it's super flexible in a way that I think is like not great. Like you can just change a bunch of stuff. Like it's very like it kind of makes it, I think, too easy, because I think that like, yeah, like I don't know. I think my opinion on this has changed over the years, right? Like, my experience has been that like, there's something that happens, like junior programmers stop being junior programmers when they hit a couple of bugs that are like so difficult they can't just solve it in a couple of days, right? Like when you get to that situation where a code base is like a year old and there's some like crazy endemic problem with billing or something, and then you and 2 other people on the team keep trying to like poke at it, and you're like, I don't understand what the hell's going on, right? That's when people kind of come out of the trough of that, in my experience, that's when they're sort of like, yeah, okay, I could see why we might want to have some guardrails, right?
Right.
And even like, oh yeah, you may be individually a really good programmer, but like, why force your mind to spend 5% of its time not doing this thing? It'll make you just write a tool, like a class once, to make it impossible for you to do this thing. If we know you should never do it, let's just do that now. Yeah, but it depends a lot on the team, I guess.
What do you see as like the next steps for this library? What's your your goal for it in the next 6 months or year?
I mean, I just wanted to put, I'm not sure if anyone's going to pick it up. Mostly I just wanted to put it out there because I'm proud of it as work and I hope someone else makes use of it. I think like looking at it in the near term, the active record support, like native active record support, is a no-brainer, sure, right? We were using Mongoloid, everyone uses active record. I prefer active record too. I also think like some of the because so many apps now are written to connect with React or whatever else, like having smart patterns, like, so the JSON serialization, right? So this, right, which is not rocket science. It's just like, oh, that's a standardized format for representing a financial amount in one or more currencies at the same time. we found on our side, in our React code, we were building a lot of little like tooling just around handling that convention. Once you have that convention, once you know everywhere on the website, this kind of data is represented this way, you can build a lot of convenience methods. So it'd be cool to like imagine building a set of like, you know, JavaScript or React tools that are specific to this kind of data. You know, we had to like, it took a little bit to think through. What did we do? So you had a view switch, right? You had a little like toggle, Euro USD. I want to see the numbers in Euro, you want to see USD. You're going, in our case, we were going through Redux, right? As a global store, that's a common pattern. And it was sort of like the display currency or something. And then it passes that display currency everywhere, right? Through Redux. Making that pattern a little easier, or sort of just like, you know, just sort of that works out of the box would be nice.
That's cool. Yeah, that's good. Have you thought about I haven't looked at the code yet, but have you thought about any opportunities to layer in type safety? I've been looking a lot at this library called Sorbet. I think Stripe developed it, but it's a type checker for Ruby. I don't know if there's an opportunity to make things stricter.
Yeah, I haven't used a lot of I haven't had a chance to work with a lot of the like the type checking layers on top of Ruby. I suppose it feels like it's only a matter of time, but so I don't really know. I would assume Sorbet like has support for like custom types, not just, I mean, yeah, it's gonna use defined types, not just text number or whatever. Yeah, I mean, you know, I'd love to see pull requests if you have thoughts on like how you might want to use that with Sorbet or something.
I may.
That'd be great.
I'm still in my early days of understanding how it works, and we're gradually typing this monolithic application we have, or at least that's the plan. So still a lot to learn, but yeah, maybe.
All right.
Cool.
Does Sorbet runs it through like it's a transpilation process, right? It
Yeah.
has to get it to Ruby for it to run.
Yeah. So you put type annotations in front of your classes and methods, and there's different amounts of strictness you can apply to your type checking, and you can choose to do it per class. So, but yeah, it's a step. I believe there's runtime type checking as well, but I think there's a sort of a step, much like TypeScript, a step that you go through to check out your types in like a build process.
I gotta say, it's so interesting to me with the optional type checking stuff, which of course like comes so much out of Node, is like, because by the way, I'm in the middle of a contract right now where I'm doing a lot of Kafka stuff, and it happens to be Kafka streams.
Yeah.
And Kafka streams is an essential part of it. Like we tried using KSQL, we can't, which means I'm writing a lot of Java code. And I'm remembering, I'm like, oh yeah, this is why we hated static types. Because Java is so insanely aggressive about you have to type absolutely everything, and you spend all this time typing and editing boilerplate code where you're like, it really doesn't, type safety doesn't matter here. It matters there, but it doesn't matter here. Like, leave me alone.
Yeah.
But like, I think that scarred like a whole generation of programmers. And then it took another younger generation of programmers to be like, actually type safety checking is really cool if you do it optionally, if you make it not super painful to use, which, yeah, it makes sense to me theoretically, you know.
Yeah.
Yeah.
Cool. Well, thank you. This was great.
Yeah, thanks.
Yep. Thank you, Francis.
I'm gonna stop sharing.
Andrew or Cliff, do we have anything else on our agenda? Any announcements, anything of that nature?
I mean, I could do a shameless plug for the Ruby Rails role that we have open at Stash.
Oh, do it.
That was the only thing. I know Andrew already recommended somebody, but at Stash we're hiring. We have a role open for our trust team. So it's not only Ruby. It's, you know, we do a lot of cross-functional programming, a lot of full stack work. So it's Ruby, it's Scala, it's Kotlin. Speaking of types, you know, we have over 4 million users, and so it's a very exciting environment. And we just raised another round of funding, our Series F. So you know, we have runway, we have customers, we have a lot to build. So if anyone's interested or knows somebody that may be interested, feel free to reach out. Cliff@stashinvest.com is my email. I'm usually good at responding within 10 to 12 hours. That's my SLA. But yeah, so reach out if you're interested.
What does the trust team work on?
Right now, they're revamping our auth system. So we are, you know, architecturally the Stash backend began like most backends do, which is a monolithic single application running in Heroku's common runtime, we are call it modernizing auth. We have a more service-oriented architecture now, and so there's you know, our custom API gateway that we've written, similar to something like Kong, which is an Nginx reverse proxy. So that's all request traffic flows through that into and routes, you know, client application requests to different services, including still that monolith. Everything goes to that monolith for auth now. So their first, you know, really big project is rethinking how you know, how the authentication experience works, and now with our tiered offering, how authorization works, what you can and can't see based on you know, what subscription you're in. So there's a plethora of work to do there. They work very closely with our cybersecurity team. They work very closely on you know, anything related to fraud, anything related to PII. So there's a lot of great exposure to the world of fintech and finance and security too, for folks that are interested. But you know, in an environment where you're you know, you're shipping multiple times a day to production, you know, we try to, you know, we strive for engineering excellence. So there's, you know, we follow a lot of patterns I'm sure other people on this call are familiar with. So we like TDD, but we don't strictly enforce it. But, you know, good, solid test coverage is a priority for all of us. Yeah, we try to push the envelope for, you know, for a lot of things too. So looking into actually open sourcing some of the stuff that we're working on as well. So yeah, good times.
Very cool. Yeah.
We deal with money,
Cool.
so you know, maybe there's an opportunity for StrictMoney.
Sure thing. Anybody else on the call? Any announcements? Anything else you want to share? Do a 3, 2, 1.
You're like one of those gavels, going once,
yeah,
going twice.
Man. Okay, everybody. Well, thank you so much. Thank you, Francis. Thank you, everybody, for calling in. It's definitely a pleasure to see, you know, new faces, familiar faces, and, you know, talk about tech, learn, keep learning, keep making the world better through many ways. Thank you very much, everybody. And I'll post a video. Hopefully the recording works. Recording's gonna work. Yep.
Thanks, everyone.
Cool. Bye.
Thanks a lot, everyone. Good night.
Good night.